This video will explain how to use the quadratic formula, why it's useful to know, and how to simplify your final answer. So here's the situation. If I were to show you a parabola crossing the x-axis like this one, and then I ask you the question, what are the zeros, which are also the solutions, you can find them very easily by looking at where the parabola crosses the x-axis. So in this case, x equals 2 and negative 3. Keep in mind, these x values are also the x-intercepts, since their y values are 0. Now here's another situation. What if I showed you this factored quadratic and asked you the same question, what are the zeros? Well, you should first change y to a 0 and then use the zero product property, which means if two binomials are multiplying together, then whatever x values make them 0 are the solutions. In this case, x equals 3. Make this binomial equal to 0, and negative 2 makes the other one equal to 0. And again, these answers are the x-intercepts, since we got them by setting the y value equal to 0. So we're still trying to find the zeros, which are also called the solutions, which are also called the x-intercepts. And I just showed you a couple of examples that can easily be worked out with what you should already know by now. But let's say you're given a quadratic that looks like this, where a, b, and c are prime numbers, very hard coefficients to work with. And maybe you think of factoring. Well, remember, y equals ax squared plus bx plus c is standard form for all quadratic equations. Factoring this would have you multiply the a and c values, 19 and negative 31, to get negative 589. So then you'd have to figure out what two numbers multiply to make negative 589 and also add to make 17. Not really interested in figuring that one out. You could graph it for sure. Here's the graph from an online resource. The zeros are right here. They look to be at maybe 1 and negative 1.8. It's kind of hard to see, so let's zoom in on the x-axis, and then here's what that's going to look like. And here are the same solutions. But clearly, they are decimal values that don't look to be at locations we can easily see and figure out. Of course, I could use a graphing tool to get the decimal answer, but we're assuming in this video that you have to answer these questions without technology to help. And so here enters the quadratic formula, the formula that will take this challenging quadratic and output the x values for the solutions. So here it is. Listen carefully and write it down. The quadratic formula is the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Yes, it's a lot. Take a moment and process that because it is your ticket to solving any quadratic equation that you get. And before we begin this, you absolutely must know your order of operations, like multiplying before adding or subtracting. And what does a square root mean? And a fraction bar means you divide the numerator by the denominator. These little things, along with other simplifying steps, are very much so needed to do this work. All right, let's get to an example now. This one has really easy a, b, and c values that you need to use because remember, a, b, and c come from standard form. And here's the quadratic formula again for your reference. So we start with taking the negative of whatever b is. In this case, it's 3. And then you write the plus minus sign. And then b to the second power goes in parentheses. Using parentheses is a very good habit to be in when doing this work. Again, though, b was the number 3. Now we're going to write down the minus 4 and put a multiplication dot. And then the value of a goes in next to it, which in this case was 2. And then another multiplication dot. And c goes in last, which in this case was negative 5. And all of that goes over 2 times the value of a, which was again 2. And now we're ready to simplify. First, that negative in front of the 3 just makes it become a negative 3. And then 3 squared is just 9. Now the minus 4ac part can get tricky, so listen carefully. You got to multiply from left to right. And negative 4 times 2 is negative 8. That negative 8 is multiplying negative 5, which makes positive 40. See what I mean about the order of operations mattering a lot? That denominator says 2 times 2, so that makes 4. Keep simplifying. 9 and 40 make 49, and the square root of 49 is 7, which brings us to the end. We now have to address the plus minus sign. It says negative 3 plus 7 over 4, and then negative 3 minus 7 over 4. Both of these simplify to give you your solutions, the zeros, the x-intercepts for this problem. Negative 3 plus 7 is 4, so we have 4 over 4. And negative 3 minus 7 is negative 10, so we have negative 10 over 4. Our first answer reduces to 1. And then the second simplifies to negative 5 over 2. And that's it. You are done. Let's go ahead and jump right into another easy one. There's your A, B, and C values. We start by taking the negative of B, which in this case is negative 7. Then draw your plus minus sign with the square root part. B squared is going to be negative 7 again. Now for the minus 4 times A part, A was 2. And then we also multiply by C, which was negative 3. All of that goes over 2 times A, which was 2, and now we have to simplify again. So let's set up a fraction bar and fill in the numerator and denominator with their simplified values. First, the negative of negative 7. It's just positive 7. So a positive 7 goes up top first. Then let's write the plus minus square root part and set that up. Make sure to draw it big and leave some space underneath it. Now we'll take that negative 7 being raised to the second power. That's going to be positive 49. And the negative 4 times 2 times negative 3 part requires us to multiply from left to right, starting with negative 4 times 2, which is negative 8. Then we multiply negative 8 by negative 3, which is positive 24. That positive 24 gets written down after the 49 underneath the radical sign. Lastly, we have that 2 times 2 in the denominator. That's going to give us 4. And now we're ready to simplify and get our final answer. Let's handle what's under the radical sign first. 49 and 24 make 73, and the 4 is still in the denominator. Since 73 is not a perfect square, we don't have to simplify it further and can just move on. The plus minus sign means we can write x equals 7 plus the square root of 73 all over 4, and x equals 7 minus the square root of 73 all over 4. Now you could stop here and be all done, but sometimes you need to give the exact answer rounded if it just so happens to be a decimal. Can we get an approximate answer? Absolutely. You don't have to leave your answer like those crazy solutions at the bottom of the screen. Start with taking that square root of 73 and converting it into a decimal by just using your calculator. You'd get approximately 8.544. And then just add 7 to that to get 15.544 and divide that by 4 to get one of your final answers, 3.886. To get the other solution, just do 7 minus 8.544. And you got that from the calculator. And then divide that answer by 4 to get the other zero, negative 0.386. These are considered approximate decimal answers where we had to round what the calculator gave us, but that's okay. Sometimes it's useful to know how to convert these answers from weird radical and fraction answers into decimals. All right, let's do a couple more. The first thing to notice is that this needs to be in standard form, where you have all of your terms on one side of the equal sign, and everything is set equal to 0. We will use inverse operations to move the 2x to the other side. So the 2x's will cancel out and the left becomes 0, which is what we need this equation to be set equal to. And then just bring the 2x over to the other side. Since none of the terms were like terms, just write the negative 2x in the middle as the b term. Now we can say that a is 1, b is negative 2, and c is 4. Now let's plug our values into the quadratic formula, starting with the negative of b, which is negative 2. Then plus or minus the square root of b squared, which was again negative 2, minus 4 times a, which was 1, times c, which was negative 4. All of that goes over 2 times a, which is 1. Set up a new fraction bar and fill in the top and bottom. The negative of negative 2 is positive 2, so write down 2 first. Then draw the plus minus square root part. Negative 2 squared is 4. And then multiply from left to right to do the next part. Negative 4 times 1 is negative 4, and then negative 4 times negative 4 is positive 16. So put a plus 16 after the 4. And then that 2 times 1 at the bottom, that just becomes 2 in the denominator. Next, 4 and 16 make 20. And then now, for something that relies heavily on another algebra topic, simplifying radicals. But before I show you this, let me just say, if you can at least get this far with these problems, that is a very good place to be at, and you are doing a great job. All right, so if this is a perfect square factor, if there is a perfect square factor in the number underneath the radical sign, then you absolutely must simplify it. The square root of 20 is just the square root of 4 times 5. And since 4 is a perfect square, you can simplify it to 2. And then leave the radical 5 alone at the end. This is what you change the radical 20 into for the final answer. There is, however, one more thing we can do to simplify. You see how we're dividing by 2? Because we have 2's in the numerator, we can actually divide and cancel out all 3 of these 2's, leaving you with this as the final answer, which can be rewritten as this. And then separating the plus minus part gives us these 2 answers to our x-intercepts, and that is it. But like I said, if you are able to get to the point where you have the square root of 20 as part of your final answer, you have been doing a great job. I just showed some fairly advanced simplifying that you would do with the quadratic formula. All right, one more for the sake of practice. Let's first get the 2x and negative 3 to the other side so we can have this in standard form. It's going to look like this. Now let's identify a, b, and c and then plug them into the formula with parentheses. The negative of b means a negative 2 goes inside the parentheses. Then draw the plus minus square root part. B squared is negative 2 squared, then minus 4 times 2 times 3. All of that goes over 2 times 2. Now let's simplify. The negative of negative 2 makes positive 2. Plus or minus the square root. Negative 2 to the second power is 4. And then the negative 4 times 2 times 3 part gives you negative 24. And then 2 times 2 is 4. The part under the radical will simplify to negative 20. So now we can rewrite it into this. And now notice there is a negative number underneath the radical sign. If you try putting the square root of negative 20 into the calculator right now, you will see an error message appear. That is because in Algebra 1, you cannot take the square root of a negative number. There's a good reason why, but this video isn't about explaining that. Instead, I will just say that this means there is no solution because you cannot square root a negative number until Algebra 2, of course. No solution in this case means if we were to draw the parabola that comes from this equation, it would be a parabola that does not intersect the x-axis. And as I've said numerous times in this video, the x-intercepts are also called the zeros, which are also the solutions. So the content has been explained and now it's time to practice. Feel free to pause the video and work out these problems. Hit resume when you're ready. I'm not explaining how to do these problems, but I will show how to set them up inside the formula and what the final answer should be. So pause the video and here we go. Thanks for watching. Please smash that like button, subscribe to my channel so that YouTube likes me more, and drop a comment if this video helped you out. See you later.